Yeah, friends, good evening. Today we are having the GTQ series 2025 for the benefit of the students who are appearing for the GATE examination in mechanical engineering. We are organizing certain important most probable questions from the subject on material science. Friends, you know that in the subject matter on material science, there are certain important chapters like crystal structures, structural imperfections, then the phase diagrams, alloys, heat treatments, effects of alloying elements, mechanical properties. These are some important areas where from definite questions can be expected. And based on my experience, I tried to consolidate certain questions for the benefit of every one of you. And today we are going to have a presentation of nearly 25 to 30 questions for your advantage. So let us try to start this session without much of delay. Taking the discussion forward, here we are having a particular question. The question reads like this: atomic radius of a hypothetical body-centered cubic metal is 0.132. Actually, it is given as millimeters here by it's a typographical mistake, small mistake. It should be 0.132 millimeters. The atomic weight of the metal is 50.9 grams per mole, and taking Avogadro's number to be 6.023 in 10 power 23 atoms per mole, the density of the metal is ABCD. Some choices are given. These type of questions are quite probable, and I wish that you must start trying to solve and then declaring the answers for this. I hope you will be able to attempt this question, right? So I wish to look into this. Yeah, Mr. Hrithik Kumar Singh, good evening. Please try to attempt this question, everyone. This type of questions are solvable by way of, say, taking up the looking into the question, we will be able to solve it. No, what we have is called as the volume density formula is to be applied here. Yes. Good evening, Priyanshu. Let's try to slide the screen and then try to note the data. We are prompted with the screen here. I am writing the solution for the benefit of every one of you. Please be noted that it is a BCC metal that is given, and for the BCC metal that is given, the average number of atoms happens to be 2, right? And atomic radius is given as 0.132 nanometers is the correct answer. Actually, it is given as millimeters by mistake. 0.132 nanometers is the correct answer. So this 0.132 nanometers happens to be 0.132 into 10 to the power of -7 centimeters, right? Then atomic weight is given. The atomic weight of the element is given here as 50.9 grams per mole. So as you look into this particular discussion, we are asked to find out what is the volume density. The formula for calculation of volume density is average number of atoms into atomic weight divided by Avogadro's number 6.023 into 10 power 23 into volume of the unit cell, that is A cube. Now we know that this data can be substituted outright. Average number of atoms is 2, atomic weight is 50.9, and then Avogadro's number 6.023 into 10 power 23, right? And volume of BCC unit cell is 4R by root 3. So this is what we write. 4 into atomic radius is 0.132 into 10 to the power of -7, that is 4R divided by root 3, that is A value whole cubed. Now this gives us the volume density as 5.97 grams per centimeter cube. Now this 5.97 grams per centimeter cube, let us see. Yes, very good, very good. Deepak Raj, good, good, good. You are giving the correct answer, Deepak Raj. Good. And Mr. Priyanshu Raj, very good. Mr. Mechanical Rockstar, I Rolex, very good, beta, very good. Kush Kumar, very good. Utkarsha Singh, fine, correct answer. Mr. Ghanta, Prasad Naidu, good, good. Anmol Kumar, good. Very nice. Ravi Raj, Priyanshu Raj, Arun Gupta, very good, very good. Congratulations to everyone. Whoever has selected, choice C is the right answer for this particular question. Choice C is the right answer. Very good. Now, with that, let's go to the next question. Come on, the next question is on the screen for you. Come on, friends. The next question reads like this. Miller indices of a direction perpendicular to 0, 0, 1 plane are. Come on, try this. Miller indices of a direction perpendicular to the plane 0, 0, 1 are. Come on, try this. I am waiting for your answer too. Yes? Yes. Friends are answering. Miller indices of a direction perpendicular to the plane 0, 0, 1. Good, good, good. People are trying. Yeah, some people have given B. Ghanta Prasad Naidu has given D. No. Utkarsh Singh C, comma D. No. Yes. Anmol has given choice B. Good, good, good. Now, let us see. Here what is happening is, there is a, there are properties of Miller indices of directions and Miller indices of planes, where we study that a plane and a direction having the same Miller indices are perpendicular to each other. A plane and a direction having the same Miller indices are perpendicular to each other. So when you follow that principle, you will be able to identify that for 0, 0, 1 plane, the perpendicular direction must be given by choice B, 0, 0, 1. Choice B is the right answer. Choice B is the right answer for that. Because a plane and a direction having the same Miller indices are perpendicular to each other. Therefore, the Miller indices of the direction should be same as that of the plane. Then only they will be perpendicular to each other. So correct choice is given by choice B for this question. Let's go to the next one. Yes. The next question is on the screen for you. Next question is on the screen for you. Come on, read it and get ready. What is the angle of intersection between 111 and 220 planes? Angle of intersection between two planes is being asked, right? Come on, I wish everyone should try. Congratulations, all those. Yes. Ashu, classes, yes, very good, beta. Good, good. And Rajanish, Raviraj, very good. B choice is given. Good, good, good. Very good, beta. Come on, go ahead. Solve this problem also. Here we try to write an answer for this particular question. That is, you have to apply the formula cos theta equal to, come on, h1 h2 plus k1 k2 plus l1 l2 divided by square root of h1 square plus k1 square plus l1 square into square root of h2 square plus k2 square plus l2 square. Come on, h1 k1 l1 and h2 k2 l2 are given. Here whatever 1 1 1 are given should be considered as h1 k1 l1. They are the indices of first plane, and for the second plane h2 k2 l2 are mentioned here. Now substitute them, you will get the answer. That is, cos theta should be equal to h1 is 1 into H2 is 2 plus K1 is 1 into K2 is 2 plus L1 is 1 into L2 is 0 divided by square root of 1 squared plus 1 squared plus 1 squared into square root of 2 squared plus 2 squared plus 0 squared. Now that implies, what's the value of, that gives you the value of angle of intersection. This angle of intersection comes out to be 35.26 degrees. Now this 35.26 degrees is mentioned in choice C. Therefore, correct answer for this particular question is given by choice C. Very good. Rajanish, very good. Rahul Yadav, Utkarsh Singh, congratulations beta. Ramurti Jha, Lokesh Mishra, Priyanshu, very good, very good. Kush Kumar, Raviraj, very good. Very good. Good. Nice that quite a good number of you are able to solve such questions very, very correctly. Congratulations. C is the right answer for this particular question. Now, another question is there in front of you. The question is reading like this. For a diamond cubic crystal structure, yes, for a diamond cubic crystal structure, there are certain statements that are given, and you are asked to identify which statements is or are correct. Very, very important question, not to be forgotten under any circumstances. Come on, friends. Though diamond cubic crystal structure is called as a cubic crystal structure, it is not the same as BCC, it is not the same as FCC, it is not the same as the simple cubic structure. It is a completely different type of cubic structure, and the speciality of this cubic structure is that it has got the number of corner atoms 8. In diamond cubic crystal structure, number of corner atoms is 8, and number of interior atoms is 4, number of atoms at face centers is 6, and therefore, if you apply the average number of atoms formula, that N average is equal to NC divided by 8 plus NF by 2 divided by plus Ni by 1, right? Corner atoms by 8 plus number of face center atoms by 2 plus number of interior atoms by 1. This is the formula for calculation of average number of atoms, as you know. Therefore, by applying this formula, using this data given in statement number 2, 3, 4 as correct, you are bound to end up with the average number of atoms as 8. That is the average number of atoms 8 is correct. Therefore, all the 4 choices 1, 2, 3, 4 are correct. Hence, choice D is the right answer for this particular question. Let us see who has answered. Very good. Yeah, mechanical rock star. Very good. Ganta Prasad Naidu, Priyanshu Raj, Comedy Q. Oh, sorry beta, आपका नाम ऐसा ही है यहाँ पर. Okay, good, good, good. And Tushar, Crystal John, mechanical, very good. Ashu classes, excellent beta, excellent. You are able to give correct answer for this particular question too. Hearty congratulations. Come on, let us move to the next one. Identify the least symmetric crystal structure out of the given questions, given crystal structures. New question is in front of you. Is it rhombohedral or orthorhombic or monoclinic or triclinic? Which is the least symmetric crystal structure? Friends, if you see, the least symmetric crystal structure happens to be triclinic, because in the triclinic crystal structure, A is not equal to B, not equal to C, and alpha not equal to beta, not equal to gamma, that is not equal to 90 degrees. Right? Due to these reasons, due to these geometrical parameters, triclinic is considered as the least symmetric crystal structure. That is the correct answer for this question. Now let us see who has given right answer. Yes, Utkarsh. Yes, very good. Least symmetric crystal structure is the triclinic. Okay, very good. Now that you are able to answer this question, hearty congratulations to every one of you. Let us try to move to the next question. Now read this particular question. This question is reading like this. There are two lists that are given to you. This type of questions you should be very, very careful. Anyway, this happens to be a simple question for you because you have come fully prepared with the subject on material science. In the list 1, type of crystal structure is given, and with list 2, the coordination number for these crystal structures is given. So select the correct answer using the codes that are given below. Come on, try. Try everyone. Try everyone. Every one of you can try this. Every one of you can try this. Coordination number. For BCC, the coordination number is 8. So A goes with 2. HCP coordination number is 12. Right? So therefore, B goes with 3. A2, B3. And then simple cubic coordination number should be 6. And for face centered cubic, the coordination number is again 12. So what should be the correct answer? It is A2, B3, C1, D3. That is choice D must be the correct answer for this. Let us see who has done it. Very good. Come on, Priyanshu Raj. Keep going. Ganta Prasad Naidu. Utkarsh Singh. Congratulations, beta. Keep going. Ashu. Very good. Very good. Keep going. I'm sure you can do it. Others, please try. Yes, Priyanshu. Very good. You are all giving correct answer, beta. Very, very good. Very, very good. Come on. Let us now take another question. Yes. Next question is on the screen, please. Next question is on the screen. A certain orthorhombic crystal, yes, has lattice parameters A is to B is to C. Yes, this is an important question. Most of you need to solve this. I expect you to do this. Has a lattice parameters of A is to B is to C in the ratio of 0.42 is to 1 is to 0.36. Very, very good. Come on, try. People are trying already. Very good. Very good. Love to nature, yeah? Good, good, good. What will be the Miller indices of crystal plane whose intercepts are in the ratio of 0.21 is to 1 is to 0.18? Yes, very good. Abhishek, excellent beta. Kush Kumar, Avinash, Priyanshu Raj, very, very good. Very, very good beta. Very, very good. So, for the help of others, let us try to do. Here, the aspect here is we are provided with A is to B is to C, right? A is to B is to C are given here as 0.42 is to 1 is to 0.36, and intercepts are to be written appropriately. Intercepts, while writing intercepts, first step, you are practiced in the classes that, come on, intercepts must be written as multiples of lattice parameters. What is the lattice parameter on first axis? 0.21. This 0.21 must be written as a multiple of first lattice parameter. So 0.21 is a multiple of 0.42. That means that multiple will become half. Similarly, the second intercept on y-axis happens to be 1. Now this y-axis intercept should be written as a multiple of second lattice parameter 1. 1 is equal to multiple of 1. That means multiple will become equal to 1. Similarly, the third intercept happens to be 0.18 and the third lattice parameter is 0.36. Now you have tried this 0.18 as a multiple of 0.36. That means half of 0.36. Hence the multiple is half. So as you go for this, in the you have to take the next step, reciprocals, that is 2, 1, 2. Very good. Next, we have to write what is called as the rationalization. In the rationalization, you are getting 2, 1, 2 only. No fractions are left out. Therefore, indices happen to be 2, 1, 2. Very good. So 2, 1, 2 are given in the so-called choice B. That is the right answer. Hearty congratulations, Mr. Utkarsh. Aman Gupta, very, very good, beta. Ankush, Irolex, Deepak Raj, Avinash, very good, beta. Correct answers. Very good. Now let us take next question. Yes, this is a theory question. You need to read this. Next question is a theory question. Read this, please. Which of the following statements is or are not correct? Be very careful. The question is asking which of the statements is or are not correct. Come on, what is this? I wish you should attempt this before I give the answer. Frenkel defect occurs when a foreign atom comes to interstitial position. B. Schottky defect in ceramic materials denotes vacancies by interstitial pair of cations. Yeah, answers start coming. Answers started coming. Which of the following statements is or are not correct? Schottky defect in ceramic material denotes vacancies by interstitial pair of cations. C. Frenkel defect occurs when an atom is displaced from its regular position to an interstitial position. Oh, people are selecting A, C, D, A, B. Yes. Hearty congratulations, Mr. Ankush Prakash. You are right. Ankush Prakash is right. A and B are not correct. A and B are not correct. You are asked to select the incorrect statements. All right. You are asked to select the incorrect statements. That's the reason why A and B are selected. Actually, what is Frenkel defect? The correct statement is given in C. Frenkel defect occurs when an atom is displaced from its regular position to an interstitial position. When an atom goes from its regular position to interstitial position, self-interstitial C and vacancy will be existing together. Therefore, that is the correct statement. C is correct. And similarly, Schottky defect takes place in ceramic materials, and this defect is created by a pair of nearby cation and anion vacancies. D is also correct. C and D are correct. But you are asked to select the incorrect statements. That is the reason why A and B are selected. Right? So don't get confused, friends. This type of questions are very much possible in every competitive examinations. Right? Normally you will be ticking correct statements. Right? But he is not asking the correct statements. He is asking you incorrect statements. Hence, A and B are the incorrect statements you are asked to select. That is why answers are A and B correct. Very good. I am happy that good number of candidates, including Mr. Deepak Raj, very good, and Mechanical Rockstar. Oh, you are all able to select the correct answer. Abhishek Kumar Mishra, very good. Super, super. Very good, beta. So happy. Now, as a reward to your good working, I am giving you yet one more question. Get ready. Regarding dislocations, find the correct statements. Now, take care. Take care. Now, you are asked to select the correct statements. Earlier, it was incorrect statements. Right? So, what does the questions read? The statement read like this. Atomic bonds undergo shear deformation in the vicinity of screw dislocations. Atomic bonds undergo shear deformation in the vicinity of screw dislocations. Is this correct statement or not? Statement number 1 is a correct statement. Keep on correcting. Next, Burgess vector is perpendicular to screw dislocation line. Burgess vector is not perpendicular, it is parallel. Therefore, 2 is not correct. Next, 3, glide motion of edge dislocations contributes to slip mechanism. Absolutely, this is correct. Glide motion contributes to slip mechanism. So, statement number 3 is correct. And statement number 4, cross slip takes place in screw dislocations. This is also a correct statement, number 4. So, 1, 3, 4 are correct. Accordingly, choice B is the right answer for this. Let us see. Wow, wow. Lokesh Mishra, very good. Beta B choice दे दिया था. Yes, B is right answer. iRolex, Anmol Kumar, Priyansh. Very good, Priyansh Raj. I am so happy you are able to answer so many questions correctly. Keep going, beta. Keep going. And Mr. Ankush Prakash, very good. B choice दे दिया था. Very good. Abhishek Verma, Abhishek Kumar Mishra, sorry. Ankush Prakash, very good, beta. Congratulations. Congratulations to every one of you who have done correctly. Choice B is the right answer for this question. Now, this is a very, very important question. Come on, read this. In a lattice structure, if vacancies are present at above and below a partial plane, it represents above and below a partial plane if there are vacancies. Come on, I love to see the question answered by you. Come on, friends. People are saying yay. No. Come on, let's see, friends. If there are vacancies present above and below a partial plane, that is how the diagram looks like, right? This is going to be an interview question also several times in the R&D organizations like BARC or ISRO. Now, if you close this particular lattice structure, it appears like a positive edge dislocation. Now, if there are vacancies above a partial plane, by closing down this lower part, it appears like a negative edge dislocation. But if you open up all, there are vacancies above a partial plane and below a partial plane. This is not mixed dislocation either. This is called as extrinsic stacking fault. Now, where is extrinsic stacking fault? Choice C is extrinsic stacking fault. That is the correct answer for this. Let us see how many have answered this. Rajiv Kumar, good, good. Ankush, very good, beta. Very good, Avinash. Abhishek Kumar Mishra, very good. Aman Gupta, super, beta. Very good. Priyansh Raj, Abhay Kumar, excellent, beta. Hearty congratulations to all of you. Let me give you one more question. Get ready. Come on, friends. Here is a question. The question is asking about, suppose iron undergoes transformation from FCC structure to BCC structure. If iron undergoes transformation from FCC to BCC structure, what will be the percentage change in density? This is the question. Come on. I wish everyone should attempt this. Yeah. Love to nature. Very good. Yeah. I should try it. Raju Kumar. Good, good, good. Yeah, Priyansh Raj. Very good, beta. Abhishek Kumar Mishra. Good. Congratulations, beta. Well done, well done. Please keep going. And other students. So here what is said is, iron undergoes transformation from FCC to BCC structure and no data is given. When there is no data, to calculate density, you know, atomic packing factor is an index of density. Atomic packing factor is an index of density. Therefore, you can calculate percentage change in density is equal to, come on, FCC is changing into BCC, na? So, atomic packing factor of BCC minus atomic packing factor of FCC divided by atomic packing factor of FCC into 100. This gives, because atomic packing factor is an index of density, if you can calculate like this, you are going to get the same value as percentage change in density. That is 0.68 minus 0.74 divided by 0.74 into 100. Come on, calculate this and let me know what's your answer. This gives you answer as minus 8.1%, and that minus 8.1 is given in choice B. Hence, choice B is the right answer. Okay. Very good, Ritik. I am glad, beta. I am glad. Thank you, God, for giving me an opportunity to serve you, beta. Yahan par bhi. Good, good. Correct answer, Ritik. Yeah, Ashu, very good. B is right answer, beta. Rahul Yadav, very good. Anmol, Rajanish, super, beta. Super. iRolex, very good. Very good, beta. Congratulations to everyone for solving this particular question also very, very correctly. Come on. Let's take up the, because you are able to solve these questions. I love to present one more question to you, as a gift. Come on, try this. This question must be answered by you, right? Definitely, I hope you will be able to answer this. Come on, try. When a formerly cold worked metal is heated to a relatively low temperature, its strength and hardness will increase and ductility will decrease. This is known as, come on, waiting for your answer. Come on. Answer. Many people are giving B, A. Oh, lucky. All are giving choice A. Choice A. Beta, choice A is strain hardening. Please, those of you, this is not so easy a question. Look into the question. एक बार इसको पढ़ लीजिए. When a formerly cold worked metal, बोले तो ऑलरेडी स्ट्रेन हार्डनिंग हो चुका है उसमें उस मेटल में फॉर्मरली कोल्ड वर्किंग करने से स्ट्रेन हार्डनिंग हो चुका है. ऐसा वाला मेटल के ऊपर आप दोबारा हीटिंग कर रहा है. सो when a formerly cold worked metal is heated to a relatively low temperature, that means if that particular metal is heated in the relatively low temperature range, then what happens? Strength and hardness will once again increase. After strain hardening, again strength and hardness will increase and ductility will decrease. This is known as. Come on, let us try to see if anyone has answered. Now, oh, so let me try to show you here, friends. Stay with your attention, please. Let me show you here. Here is the load versus elongation diagram for a low carbon steel. For example, load versus elongation diagram for a low carbon steel. Suppose initially you go for cold working. Initial cold working is represented by the graph like the load versus elongation diagram coming like that. This is first stage is cold working. After this cold working is over, if you try to heat this particular material in the low temperature range of around 180 to 250 degrees centigrade, what's going to happen is whatever the carbon and nitrogen interstitials are there, they will go to some other locations, and after going to some other locations, they will start creating new quadral atmospheres. When they create new quadral atmospheres, again they start the stopping of the dislocations, and hence the second time strength and hardness will increase and ductility will decrease. That means if you try to heat this particular material and then again subject it to cold working, for the second time when you go for cold working, you identify that the graph rises like that. The graph rises like that, and then it can be brought back to room temperature. Now this time what is happening is, the second one is what is being questioned. Now understand the question. When a formerly cold worked metal is heated to a relatively low temperature range, in the relatively low temperature range of 180 to 250 degrees centigrade like that, its strength and hardness increases. Its strength and hardness will increase, ductility will decrease. Second time, whatever the ductility you are realizing here, it is less than the first time ductility. Now question is on this, what is this known as? This is called as, yes, मैं अभी इंतजार कर रहा हूँ. Come on बेटा, very good. दीपक राज और उदिशा सिंह, fantastic beta, fantastic. What is the answer? It is called strain aging. C is the correct answer. It's called as the strain aging. I am happy that there is at least one question that is becoming useful to you now. Yes, Priyanshu Raj, very good. Aman Gupta, C, very good. Deepak Raj gave C answer, very good. Congratulations beta, we started counting on you. And I am sure that you must get into the wonderful careers this time. Come on. So one more gift is coming to you, right? Another presentation from Medici to you. That is next question, please. Come on, friends. See this question and try to answer it. List 1 and list 2. In list 1, phases in the steel are given, and in list 2, crystal structures are given. You are supposed to match them. Come on. Yes, very good, very good, very good. Phases in the steel are given, and you are asked to match them with their corresponding crystal structures. Correct? Very good. Very good. Many people are answering. B is the right answer. Okay. Are you able to get that? Come on, let us see. Ferrite is BCC in crystal structure. So A goes with 2. That means B or C. Austenite is FCC. That means B goes with 4. A2, B goes with 4. Come on. Martensite is BCT. That is 3. C3. Yes. Therefore, B is the right choice. Congratulations. Right. Similarly, cementite is orthorhombic. Cementite is orthorhombic. Therefore, correct answer is given by choice B. Hearty congratulations. Everyone. Very good. Avinash Kumar, Aman Gupta, Atul Singh. Congratulations, beta. Ritik, Rajiv Kumar. Good, good, good. Golu Kumar, Mr. Kush Kumar. Very good, beta. Very good. So, that area you are all able to concentrate very well. Done deal. Done deal. If a question comes on that area, you will be definitely in a position to answer. Very good. Very good, beta. Come on. Let us try to take the next question. A gift to you. One more gift to you. Come on, friends. The question reads like this. In a binary alloy system, what is the maximum number of phases that can be present with pressure when pressure is constant and temperature is the only one variable? And temperature is the only one variable. Come on, try. Please try. Answer. Yeah, very good. Many people are replying it. The answer is C. Fantastic, beta. Fantastic. So, in a binary alloy system, when you are required to find out the, you are asked to find out what is the maximum number of phases. Come on, P plus F is equal to C plus 1, right? Binary alloy system. Therefore, C will be equal to 2. Hence, we can write P plus F is equal to 3. You are asked to find out the maximum number of phases. So, P can be written as 3 minus F. Then, if P has to be maximum, then F must become 0, right? When F becomes 0, therefore, maximum number of phases must be equal to 3. And that 3 number of phases is given in choice C. Hearty congratulations. Hearty congratulations, everyone. Yeah, C3 Avinash, very good. Rajanish. Rajiv Kumar, good, 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 beta. Deepak Raj. Ankit. P plus F equal to C plus 1. Yeah, you have to apply. You have to apply and give the answer in time, correctly. Good, good. Raviraj Kumar, good, beta. Good, good. Now, keep going. Keep going. Everyone. Once that is done, next, we'll give you one more question. Get ready. We'll give you one more question once you are ready. Okay? Come on, take this particular question, please. Yes. Try to solve this. Try to solve this. Now, since this is a question on phase diagrams, what is the type of phase diagram that you are coming across? It is given clearly, very clearly. They form eutectic at 200 degrees centigrade, right? So you have to take the eutectic phase diagram into consideration and then proceed with the solution. So let us try to represent the data on a phase diagram. The phase diagram can be drawn here itself, right? Eutectic phase diagram. It's given like that. The 100p 0q composition is here. 0p 100q composition is here, right? And here is the eutectic phase diagram. In the eutectic phase diagram, at eutectic point, the composition given is 60p 40q, right? And the temperature here is 800, that is given. Temperature here is 600, right? They are forming eutectic at some temperature like about 200 degrees centigrade. At eutectic, it is forming at 200 degrees centigrade. These two elements are forming the eutectic, and you are asked to say, you are asked to identify. Come on. For the alloy which is containing 50% P, 50% P alloy will be here. So 50% P means it will also contain 50% Q, right? You are asked to identify it contains how much amount of Q and how much amount of P, or how much amount of Q and how much amount of eutectic. Come on friends, when you take this particular alloy and this temperature, eutectic temperature is given, you can consider this as the fulcrum F, and it is passing through this two-phase region. In this two-phase region, on this side you are going to have Q, right? So this point is C. Let us say, for example, let me identify the points with a different color for clarity. This is point C, this is point D. Now you can calculate, at C the phase is eutectic, at D the phase is Q. At C the phase is eutectic phase, right? So if you apply lever rule, you are going to have a weight percentage of eutectic is given by lever arm FD, right? So let us try to move this screen to a side and then try to do. Yes. So we can write that weight percentage of, we can write weight percentage of eutectic is equal to, come on, weight percentage of eutectic is given by FD divided by CD into 100. What is that FD? FD, you can substitute either in terms of P or in terms of Q. So 50 minus 0 divided by CD is 60 minus 0 into 100. That comes out to be 83.33%. That is eutectic. If this is the eutectic, then you can understand the weight percentage of Q. Weight percentage of Q should be equal to 100 minus weight percentage of eutectic. Weight percentage of eutectic. That means it is 100 minus 83.33. That comes out to be 16.67%. Right? So weight percentage of Q is 16.67% and weight percentage of eutectic is 83.33. So with that solution, let us identify which is the correct answer. Choice D is the right answer. Let me see. Wow, wow, very good. Very good. I see 4-5 names here. Abhay Kumar, Keshav Kumar, very good. Correct answer, beta. Mechanical Rockstar and Deepak Rai, very good. Rajiv Kumar, Abhishek Kumar Mishra, Priyanshu Raj, very good. Correct answer. Keep going. That should be the spirit. Very good. Keep going. Now, let us try to give you one more good question. Get ready, friends. I am sure today I will give you Definitely some good questions and you will enjoy them. Yes. Try this. Try this question. Try this question, please. Find the ratio of pro-eutectoid cementite to total cementite in 1.5% carbon steel. Come on. When it is cooled from above A1 to below A1. Come on, friends, let us try to see. For this, the relevant phase diagram that is to be drawn is the iron carbide diagram. So come on, let us try to draw a part of the iron carbide diagram that is needed to support the calculations. Right? The data that is furnished is like this. We can take, for example, the eutectoid composition is 0.8 and then the given composition of steel. The given composition of steel is 1.5% composition, 1.5% carbon containing steel, right? That is the steel given. And steel is cooled from above A1 to below A1. Therefore, here you are going to have gamma plus cementite, right? Now, this cementite is what is called as pro-eutectoid cementite in the steel above A1. Now, A1 is this particular line called as A1 line, okay? Now, let us try to estimate weight percentage of pro-eutectoid cementite is equal to cementite P, means pro-eutectoid cementite is equal to. Where do you take the pro-eutectoid cementite calculation? Always above A1. So take a tie line here, take a tie line here. Now this is point C, here is point fulcrum F, and this becomes the point D, right? Now at D, the phase which is present is cementite. Above A1 at D, the cementite present is called as the pro-eutectoid cementite. Therefore, pro-eutectoid cementite is given by CF divided by CD into 100. Since you are asked to find out only ratio, you need not calculate percentage. So you can simply write what is called as weight fraction of. Percentage need not be calculated, because finally you are going to calculate only ratio is what is asked. So CF by CD, what is that CF by CD going to be? At F it is 1.5% and at C it is 0.8% divided by CD. At D the carbon content is 6.67%. Therefore, we write 6.67% minus at C it is 0.8%. Now, if you calculate this, it is going to be 0.11925. Similarly, we try to calculate now what is called as the weight percentage of total cementite or weight fraction of total cementite. Weight fraction of total cementite is equal to, you know, total cementite is to be calculated below A1 by taking a tie line here just below A1. Now this line, this point becomes C, here this point becomes the fulcrum F, and this point becomes point D. At D, whatever the cementite you are having is the cementite below A1, that is total cementite. It is given by CF divided by CD. What is that CF? 1.5 minus at C, what will be the carbon percentage? 0.025 divided by CD, 6.67% minus at C it is 0.025. So this is giving you the total cementite as 0.22197. Therefore, ratio of pro-eutectoid cementite to total cementite Fe3C total is equal to, come on, 0.11925 divided by 0.22197. This gives you the answer as 0.537. That is the answer for this particular question. Let us see. Wow, good. Aman Gupta, very good. Priyansh Raj, fantastic beta. Abhishek Kumar, Rajanish, Abhay Kumar, you have given me only one answer beta. Yeah, Priyansh Raj, 0.119 is only pro-eutectoid cementite. Right? You have to give me the ratio. This question is asking the ratio of pro-eutectoid to total cementite. Okay, very good Rajiv. Utkarsh Singh, congratulations beta, keep going. Yeah, Abhay Kumar, you are right, total cementite is 0.2219, very good. Golu Kumar, 0.5361, very good. थोड़ा सा verify कर दीजिए Golu Kumar. The answer should be around 0.537. Yes, Lokesh. Misha, you are right. Abhay Kumar, correct है बेटा, very good. Congratulations everyone for this meticulous approach. You are moving forward with all the care. My only request is there are a few candidates. I am able to see in a serious intention to quickly solve the problem. You are only reading half the problem. So my request to you, this is going to be dangerous. So no issue. You can overcome it. And remember always, there is always a possibility for improvement. Tomorrow you will be much better than today. That is why tomorrow comes into our life. Yes? Come on, go ahead. You can do it. You can do it better. Next question, please. Yeah, it's on the screen. What is the percentage of pro-eutectoid ferrite to total ferrite in 0.2% carbon steel, assuming eutectoid reaction takes place at 0.8%? Fantastic question. Come on, friends. Again, you have to draw the same diagram. Iron and carbon diagram. Here, 0.8% carbon content here. Here it is 0.025, and given alloy is having 0.2% carbon content. You are asked to find out what is the percentage of pro-eutectoid ferrite to total ferrite. So let us try to write, that is weight fraction of pro-eutectoid ferrite. Instead of writing so long, we can simply write alpha pro-eutectoid ferrite is equal to. How do you find pro-eutectoid ferrite? You have to take a tie line just above A1. So this point will be C, here is F, and this is point D. So what is the pro-eutectoid ferrite? Pro-eutectoid ferrite will be equal to FD divided by CD, FD divided by CD. How much is that going to be? It is 0.8 minus 0.2 divided by 0.8 minus 0.025. This gives you as 0.7742. Similarly, we write the weight fraction of total ferrite, alpha total, that is total ferrite, is equal to. How to find total ferrite? Total ferrite is to be calculated below A1. Here, So when you draw this tie line here, this point becomes C, and here is fulcrum F. This is point D. Now, if you want to calculate total ferrite, it is given by pink color FD divided by pink color CD. Now that gives you pink color FD. At D, what is the carbon content? 6.67%. Therefore, it is 6.67 minus 0.2 divided by CD is 6.67 minus 0.025. This comes out to be 0.97366. Therefore, required ratio, that is ratio of pro-eutectoid ferrite to total ferrite. Pro-eutectoid ferrite to total ferrite is 0.7742 divided by 0.97366. This gives you the answer as 0.7951. That will be the answer. So let us see how many of you have given correctly. Acha, you are asked to report the percentage. Percentage is to be reported. You are not asked to report the ratio. Therefore, the ratio is given. Now, instead of ratio, because the question is asking you about the percentage, it implies that this percentage is 79.51%. You are right. This is the answer. Right? This is the answer. 79.51 is the right answer because percentage is being asked in this question. Very good. Come on. So nice, Utkarsh, Golu Kumar. And yes, I Rolex. Very good. Keshav Kumar. Good. Rajiv. Correct answer, beta. Please check. It is around 79.51, beta. You are getting 0.8. Okay. Good. Kush Kumar. I am able to recollect certain names here. Priyanshu Raj. I came across you somewhere in my online classes. Am I right? Good. Abhishek Kumar Mishra. Good. Ankit. Fantastic, beta. Very good. Ashu class. Very good, beta. Good. All are doing very well. Yes. Glad to meet you here, Priyanshu Raj. Very good, beta. You were equally dynamic in the earlier classrooms also. Huh? So nice. I am happy to see you participating so dynamically in the class. So nice. Yes. Dinesh Soni. Good, beta. Roni. Fantastic. Good. Come on. Shall we take the next question, please? Yeah. Hardenability is increased by. Huh? Now the question is coming up. Hardenability is increased by. There are 4 choices that are given to you. Coarse grain structure, homogeneous austenite, carbon content, alloying elements. Out of these 4, what's that? Oh, fantastic. Some of my friends are giving good answer. Yes, D is the right choice. Tushar, it's not C, beta. D. Can that be D? No. Come on. Yes, Avinash has given answer. B is the right answer. Choice B for Bombay. Abhay Kumar. C de diya beta aap. It should be B. Hardenability of steel can be increased by. Come on. Hardenability of steel can be increased by all the 4 parameters. All right. All the 4 parameters are right. Yes. B is the right answer, and B choice is given by Ashu. Very good. And Rajanish, Abhishek Kumar, Raviraj, fantastic. Deepak Rai, hearty congratulations, beta. Friends, let me give you a word of caution here. That for this particular question, you know, fine grain structures have so many number of grain boundaries. This question is set only to cause confusion to you regarding coarse grain, fine grain. Fine grain structure has several grain boundaries, and grain boundaries will absorb the cooling rate. Therefore, where there is a fine grain structure, critical cooling rate will increase. Fine grain structures have higher critical cooling rate and lower hardenability. Coarse grain structures have less number of grain boundaries. Therefore, they absorb less in respect of the cooling rate. So, what is going to happen? Coarse grain structures will have lower critical cooling rate and higher hardenability. Therefore, coarse grain structures will increase the hardenability. Similarly, homogeneous austenite means single phase austenite, right? If there is any pro-eutectoid phase associated with austenite, that is called heterogeneous austenite. That heterogeneous austenite will increase the critical cooling rate, therefore reduce the hardenability. Only homogeneous austenite will decrease the critical cooling rate and increase the hardenability. Similarly, carbon content. By increasing the carbon content, hardenability of the steel can be increased, because compared to low carbon steels, medium carbon steels are having lower critical cooling rate. Compared to medium carbon steels, high carbon steels are having much more lower critical cooling rate. Therefore, by increasing carbon content, hardenability can be increased because critical cooling rate decreases. Then by increasing alloying elements, alloy steels are having more important effect, more significant effect on critical cooling rate. Comparing between alloying elements and carbon content, alloying elements can drastically decrease the critical cooling rate. Therefore, alloying elements will result in decreasing the critical cooling rate and increasing of hardenability. Hence, we say that all these four are correct choices for increasing the critical cooling rate. So, correct answer is given by 1, 2, 3, 4. Fantastic. Good. Rajanish has given. Ashu has given. Abhishek Kumar Mishra, Raviraj Kumar. Good beta. So glad that you are able to give correct answers. All these four parameters are going to give an increased hardenability in case of steels. Come on, let me see again. Next question, please. Yeah. The heat treatment process used for softening of hardened steel is, come on, try this. What is the answer? I am sure you will be able to pick it up. The heat treatment process used for softening of hardened steel is, fantastic. Ankit has given correctly. The heat treatment process used for softening of hardened steel. Yes. Rajiv Kumar, Priyansh Raj, you have committed a small mistake, but it is not C. Again, look into the question. You are not asked about softening of the steel. You are asked about softening of hardened steel. Come on, check that. Yes. Always remember, friends, this question is not asking you about softening of steel. It is asking you about the heat treatment process to be used for softening of hardened steel. Here is the emphasis. What is the raw material? Raw material can be cold worked steel. Raw material can be cast steel. Raw material can be welded steel. Raw material can be hardened steel. What is the raw material? If it is a cold worked steel or welded steel, then it is annealing. If it is a cast steel, then the correct answer is normalizing. Because how do you achieve softening? Softening is achieved by relieving the internal stresses. Then, what is causing the in a non-availability of softness in hardened steel? Internal stresses. So, how do you relieve internal stresses? In a hardened steel, that is by tempering, right? In hardened steel, internal stresses are relieved by tempering, and by tempering only it gets softened. So, correct answer always is tempering better. This is a very, very important question. I know this question was asked several times in the competitive examinations. Therefore, I request every one of you kindly be careful about such type of questions, right? This type of questions are very, very, troublesome. Be very careful. Yes, correct Priyansh Raj. Shukla, Abhay Kumar. Yes, Utkarsh. Rajanish, you're right, beta. So nice, so very glad. So very glad, beta. Come on, friends, let us see. Next question. See this question, please. The question is on the screen for you. It reads like this: match list 1 and list 2. List 1 is the heat treatment process, ash tempering, ash forming and mass tempering, and list 2 is representation on TTT diagram. You are asked to identify, you are asked to match the two lists. Come on, I am waiting for your answers. Come on, friends. Yes, fantastic. Fantastic, beta. Yes, Utkarsh, Anmol, Comedy Q, Kushkumar, Priyansh Raj, fantastic. This time, almost all the students have given the correct answer except Mr. Tushar. तुषार डी चॉइस दे दिया बेटा, वो देखो एक बार. What is the correct choice? It should be 2, 3, 1. चलो. Ash tempering. Ash tempering goes with the 2 here, because in ash tempering you are going to use a critical cooling rate more than that of the, you are going to use a cooling rate more than the critical cooling rate, and then isothermally hold the steel until the cooling rate curve enters into the bikinetic region, then you will cool it to room temperature. That is ash tempering. In ash forming, it is this, that is, after cooling at a rate more than the critical cooling rate, you are going to subject the steel to rolling or forging, and then it is followed by cooling to room temperature. In mass tempering, this is mass tempering. 1, 2, 3, 1 are the correct answers. In mass tempering, the austenitized steel is cooled at a rate more than the critical cooling rate, and then held at that temperature for a short period of time, followed by subsequent cooling to room temperature or below room temperature. So 2, 3, 1 is right choice, and 2, 3, 1 are given in choice B. Therefore, it's correct. Yes, correct, Keshav Kumar. It is nothing but hardening with multiple stages of hardening with intermediate quenching. So B is the right answer. B for Bombay is the right answer for this question. Very good, very good. Keep going. Let me give you another question. Are you all ready? Okay, dosto. Take this as a gift. One more. Read this. Which of the following heat treatment processes is or are described correctly? So you try to identify. A question on mass tempering, ash forming can come with representation on TTT diagram, or it can also come in terms of this type of description. Let them give any type of question, you should be willing to answer it correctly and within the right time, right? Come on, in mass tempering, austenite is converted into bainite. Is this correct? Right? It's not correct. In ash tempering, austenite is converted into bainite. Correct. This is right. This is right. Next, in mass tempering, austenite is converted into martensite. In mass tempering, yes, in mass tempering, austenite is converted into martensite. This is right. Next, in ash tempering, austenite is converted into martensite. Right. In ash tempering, austenite is not converted into martensite. So what are the correct answers? B and C. Are they right answers? Let's see. Yes. Avinash, Utkarsh Singh, Rajiv Kumar, very good beta. And Abhishek Kumar, B and C, very good. And Ankush, one choice is correct beta. C is correct, D is not correct. In ash tempering, austenite is not converted into martensite. हो सकता है बेटा, ऐसा situations में थोड़ा सा टेंशन हमारे साथ साथ रहता है. So please try to take care of tensions, because having intention is not bad, but having tension is bad, right? Having intention is a great virtue. You want to become great, that is your intention. That intention itself is a divine virtue of life. But if you have tension, that will damage all your achievements, all your reputation, all your knowledge, all your memory. Therefore, let us not have any tension, only intention. All right? Good, good. So, let us take up. Next question. Come on. Yes. This is a question I want you to answer, please. Let me see how many of you will be able to answer this. Match list 1 with list 2. Some alloys are given in list 1 and corresponding system of alloys, like system of phase diagram is given here. Alloys and alloy system. Alloys are given in list 1, alloy system is given in list 2. Match them properly. Come on. Let me try to see who does correctly. Yeah, come on, answer this. Why delay? Avinash is answering all D. Okay, there is some stick case. I understand. Ankit, can it be D? No, beta. This type of, so I understand this type of, most of you are including Abhay Kumar and Irolex, Tushar. No, beta, it's not A. It cannot be A. Come on, let us see. Lead tin alloys are lead tin alloys, tin bismuth alloys, thorium titanium alloys. They are all eutectic alloys. So let us see. Lead no, it is lead arsenic alloys, right? Come on. Lead tin alloys are partial eutectic alloys. Lead tin alloys are partial eutectic alloys, not the eutectic system alloys. These are partial eutectic alloys. Silver copper alloys, lead tin alloys, tin bismuth alloys, cadmium zinc alloys, they are all partial eutectic alloys. And copper nickel alloys are isomorphous alloys. Copper nickel are isomorphous. So A4B1, all right, choice C. Then thorium titanium alloys, bismuth cadmium alloys, lead arsenic alloys, they are all eutectic alloys. So thorium titanium alloys are eutectic system alloys. Then silver tungsten alloys are insoluble in both liquid and solid states. So layer system alloys, D goes with 3. D goes with 3, C goes with 2. Therefore, answer is C. Choice C, beta. Yes, I am happy. Abhay Kumar has set his answer right. Yeah, Sumant, Sai Sumant. Great, very great evening. Namaskaram. Hi, yeah. Certainly, Sai Sumant. All fine. And I hope the same with you, Sai Sumant. Very great. Glad to see you here. Very good, beta. Very good. Keep going, Sai Sumant. And Aman Gupta, very good. Abhay Kumar and Aman Gupta have given correct answer. Laukesh Mishra has given correct answer. Rajiv Kumar, good. Priyansh Raj has given correct answer, beta. Very good. Now that this question is also successfully answered, beta, I see that, yes. One possible situation where students normally forget or answer these questions incorrectly is, because they don't remember. What happens is, beta, whatever जो examples आपको क्लास में दे दिया जाता है टीचर की तरफ से, वो सारे examples important है बेटा, याद में रखने का चीज होता है. So please try to remember them, at least until the examination. And once exams are over, you forget them. Right? So that is how you can make your life made easy. Right? Chalo. Come on, beta. Because, you know, living to the best comfort. What is the best comfort? Achieving success is itself the best comfort. Right? So in between, a teacher is the experienced person. When he gave you all these examples in the class, beta, it is meant for your memorizing. So please remember those things and then practice them for future. Next question, please. Yeah. Fantastic question. आपके सामने. A very, very fantastic question is there in front of you. A very, very fantastic question is there in front of you. Read this and then try to solve. Come on, beta. Iron carbon alloy, mass fractions of total ferrite and total cementite are found to be 0.88 and 0.12 respectively. Assuming eutectoid composition is 0.76% carbon and cementite contains 6.67% carbon, ferrite contains 0.022% carbon, then given iron carbon alloy is very good question. Come on, let us try to see this. Everyone, please attempt on your own. If you have confidence, attempt it. Don't wait for me. Now here, the so-called phase diagram is to be drawn for the part that is necessary. Right? Now what is given is, eutectoid composition is given as 0.76 and ferrite contains 0.022% of carbon. Here it is given. Similarly, here it is 6.67% carbon. That is also given. Now what is given is, suppose some hypothetical alloy is being given. For a hypothetical alloy, let me indicate that hypothetical alloy of iron and carbon by some composition. Suppose the composition of the given alloy is that it is having X percentage of carbon. Suppose X is the percentage of carbon in the hypothetical iron carbon alloy. In the hypothetical iron carbon alloy, X is the carbon content. Then what is given is that a statement is given. Mass fraction of total ferrite is 0.88. Mass fraction of total ferrite is 0.88 and mass fraction of total cementite. Mass fraction of total ferrite is 0.88 and mass fraction of total ferrite is 0.12 respectively. Right? Now, for example, use this and then try to solve. That is, let me try to shift it to here. Yes. Now, how do you get the mass fraction of total ferrite? To get the total ferrite, we have to take, a tie line here, as I have already explained earlier. Now, this point is C. Here is fulcrum F. This is point D, right? At point C, the ferrite which exists is called as the total ferrite below A1. So, the total ferrite is given by lever arm FD. So, I write here, that is mass fraction of total ferrite alpha total is given by FD divided by CD. What is FD? As per the data that is present there, FD is 6.67 minus X divided by CD is 6.67 minus 0.022. Now, what is this mass fraction of total ferrite? It is given that this left side is 0.88. So, it is equal to, come on, 6.67 minus X divided by 6.67 minus 0.022. Now, if you solve this, you are going to get the value of X here as 0.82. This 0.82. This X is nothing but carbon content in the given alloy. It is the carbon content in the given alloy. In the given alloy. All right. In the given alloy, that is the carbon content. Now, if you compare this with eutectoid composition given, eutectoid composition is 0.76. The carbon content in the given alloy, is more than the eutectoid composition. So, since X is more than 0.76 per, that is eutectoid composition. Therefore, the given alloy or the given steel is hyper-eutectoid steel. Given steel is hyper-eutectoid steel. Now, if you examine this answer, hyper-eutectoid steel is tallying with which choice here? It is tallying with choice D. No, it is tallying with the choice C. So, choice C, let us see. Good. Rajanish, Avinash, Abhay. Abhay has given wrong answer D. Abhay, please verify your calculations. Ankit. Yes, cast iron is only after 2% beta. You are right. 2.1, 2 or 2.1%. Both are acceptable, right? Correct, Utkarsh. Vaibhav, very good. Abhishek Kumar Mishra, congratulations, beta. Well done. Ashu, good, beta. Now, you're almost done. You're almost done with the questions that are related to the phase diagrams and heat treatment. Beta, very good performance. As usual, I see in most of the gate examinations, the students do reasonably well or very well in the material science without any hesitation. Therefore, as I see your performance, I am sure you will be able to do very well in this time also, gate examination, right? You will do very well. Come on, take the next question. This is a question related to effect of alloying elements in steel. Effect of alloying elements in steel. Read this. Which of the following statements is or are correct regarding effects of alloying elements in steel? Which is correct, or which of the following statements is or are correct? Come on, friends. Make it. Try out, please. Anyone is answering? Very good. Whoa. Avinash Kumar, you are perfectly correct, beta. Ankit, correct. Very good. All these four silicon containing steels are used in transformers for low power losses. Correct. Why? Silicon makes the steels magnetically soft. That is why it reduces power losses. Hence, statement A is correct. Nickel containing steels are used for low coefficient of thermal expansion. You know, invar steels containing 36% of nickel are used for low coefficient of thermal expansion. This is correct. Manganese containing steels are used for wear resistance applications. High manganese steels containing more than 10% to 11% of manganese are called as Hadfield manganese steels. They are used for wear resistance and non-magnetic applications. Choice C is right. Choice D. Steels containing more amount of sulfur should not be used for hot working because sulfur results in hot cracking tendency. When there is more amount of sulfur results in hot cracking tendency in steels. Therefore, such steels should not be used for hot working applications. A, B, C, D, all the four are correct. Very good. Very good. Yes, Ankit, hot sharpness. Very good, beta. Correct. Very good. All the four are correct. So nice. Yes, correct. Priyansh Raj, all correct, beta. Perfectly correct. Now take the next question coming in front of you. Come on, regarding creep resistance, which of the following is or are correct? Come on, friends. You know, actually this particular first choice, the statement here is it is fine grain structures. Fine grain structures are preferred compared to coarse grain structures. Is it so? Huh? No. Creep resistance, for want of better creep resistance, coarse grain structures are best. So statement P is wrong. You are asked to select the correct statement. Materials having low melting point are not preferred. This is correct. Come on, देखो तो यहाँ पर कितना twisting कर दिया. Materials having low melting point temperatures are not preferred, means high melting point temperature materials are preferred. Correct or not? So that is correct statement Q. Next, polycrystalline materials are preferred compared to single crystal materials. This is wrong. Because grain boundaries are going to be culprits for creep applications. Single crystal materials are used for gas turbine blade manufacturing applications. They are used in creep applications. Single crystal materials are preferred, but here sentence is given reverse. R is incorrect. Dendritic structures are preferred compared to equiaxed structures. What is this? This is equiaxed structures. Equiaxed structures. Dendritic structures are preferred compared to equiaxed structures. Right? Come on. Hope you are able to come up with the correct answers. Which of the following statements is or are correct? Q and S are the ones which are correct. Materials having low melting point are not preferred. This is a correct answer, a statement. And dendritic structures are preferred is a correct statement. Let us see how many students have answered it correctly. Abhi tak no. Now, Mr. Ankit, dendritic formation takes place. You know, dendrite dendrites are formed during solidification process. Ankit, dendrites are formed during solidification process, and these dendrites are randomly growing solid phases in molten metal. They grow as a function of time and temperature. Dendrites grow from molten metal. They are solids, randomly growing solids. They grow as a function of time and temperature. Okay, Ankit? Yeah. Ankit, Q and S is correct. Q and S, both are correct. Yeah, Raju Kumar, Q and S. Avinash Kumar, only yes. No, beta. Q is also correct. Avinash, read that question, the statement number Q. That is just given as a tongue twister. Materials having low melting point are not preferred. That means correct. That indicates that high melting point materials are preferred. So Q and S, Rajiv, correct answer. Avinash, you're right. Okay, good, good, good. Next. Read this question. The next question is on the board, please, for you. Next question is on the board for you. Read that question and try to solve it. You know the importance of this particular question. What's the importance of this particular question? This was given in one of the gate examinations, not with the same data, of course. Right? Now, try to solve it and let me have the answer from you. What's the answer for this particular question? Yes. Yes, beta. Good, good. Come on. The goodness of this particular question is that, friends, length data is not available. Without knowing length data, you should find out the engineering strain. If you can find out the engineering strain Rest of the things are quite normal. So let me try to show this in a way here, so that it will be helping the other students as well. Come on, friends. Let me try to write the data here, that is initial diameter is given, solution. Initial diameter is given here as 10 millimeters, right? And final diameter is given as 7.9 millimeters, right? And engineering fracture stress is given as 400 megapascals. You are asked to calculate what is the true fracture stress. This is the question. Now you know true fracture stress is equal to engineering fracture stress into 1 plus engineering strain, right? True stress is equal to engineering stress into 1 plus engineering strain. This is known to everyone. But what is engineering strain? We understand here. But engineering strain is normally given by the expression, that is LF by LI minus 1, or this is equal to DI square by DF square minus 1. This is how we try to calculate the so-called engineering strain. So here we write, but engineering strain is given by this formula. Now if you are having length data, final length, initial length, use this. If you are not having length data, diameter data is available, use this and find out the engineering strain. So to find out that, engineering strain is equal to 10 square, initial diameter 10 square divided by 7.9 square minus 1. This gives you engineering strain as 0.6023. Alright. Now once you have this, then we write true fracture strain is equal to, true fracture stress is equal to, engineering fracture stress is given 400 into, come on, 1 plus 0.6023. That's all. That gives you the answer as 640.923 megapascals. This is the answer that is given in choice C. So choice C, let us say, no, it's not choice C. Choice B is correct, 640.923 megapascals. Let us see how many of you have done it correctly. Fantastic, Deepak. Very good. B is correct. B is correct, Abhishek. Anmol, good beta, good. Keep going, Rajanish. Correct. Okay. Yeah, Utkarsh, there may be minor variations in the answer beta, but you have to search for the nearest answer and then tick the answer. All right. Very good. Come on, keep going. Let's check if there is anything more. That's the answer for that question. Yeah. Another question is there in front of you. On the screen, please. The reduction in the yield stress of a material subjected to loading in completely opposite directions is known as Helsinki effect, Misner effect, strain softening, or Boschinger effect. Yeah, I am waiting for your answers. Correct, Ankit, very good. Utkarsh, good beta. Keshav Kumar, not correct. Deepak Raj, correct. I Rolex, correct beta. Abhishek Kumar Mishra, very good. Rajneesh, very good beta. Rajneesh, Anmol, Rajiv Kumar and Priyanshu, very good beta, correct. Boschinger effect is the right answer. Boschinger effect is the correct answer. Reduction in the yield stress of a material subjected to loading in completely opposite directions is known as the Boschinger's effect. Very good. Come on. Let's now move about next. Rearrange the following materials in the decreasing order of malleability. Another very, very important question in front of you, please. Rearrange the following those materials in the decreasing order of malleability. Come on. Can you attempt? Try out. Come on, friends. People have started giving the answers. All are voting for B. And that should be correct. Very good. B is the right choice, beta. B is the right choice for that particular question. B is the right choice for that particular question. Come on, let us see. Next question, please. Next question. On the screen, please. In a Charpy test, mass of the pendulum is 55 centimeters and the radius of the pendulum, length of the pendulum is 55 centimeters and its mass is 5 kilograms, right? If angles of fall and angle of rise during the test are 85 degrees and 15 degrees respectively, then the dynamic toughness is. Friends, you know, we calculate dynamic toughness. Dynamic toughness is calculated as a difference between, come on, mg into capital H minus small h, that is initial potential energy is mgh, capital mgh, mg into capital H is initial potential energy. Final potential energy is mg into small h. Now, by using the radius and all that, capital H value, small h value are to be calculated. So, directly I am giving you a formula here instead of deriving in the class here, because it's not a regular classroom. I don't want to trouble your time. So, we try to calculate this as mg into m into g into capital R, that is length of the pendulum, into cos beta minus cos alpha, cos beta minus cos alpha, right, where beta is angle of rise, that is given as 15 degrees, and alpha is angle of fall of the pendulum, it is given as 85 degrees, and R is length of the pendulum given as 55 centimeters, or you can substitute in terms of meters, 0.55 meters, 0.55 meters, right. Next, the m value is given as 5 kilograms and g is 9.81. Substitute them and then get me answer. Just substitute them and get me the answer. G is 9.81. Very good. G is 9.81 beta. Okay. So, people have already started declaring the answers. Hearty congratulations. Well done. Rajanish. Well done, beta. Abhishek. Rajiv Kumar. Good. iRolex Vaibhav. Very good. Priyanshu Raj. Fantastic, beta. Correct. So, B is the correct answer for this particular question. B is the correct answer for this question. Very good. Now take the next question. Ready? Yeah. The question reads like this. Fatigue life in vacuum. The question is reading about fatigue life in vacuum is 10 times more than that in the moist air. This is due to fatigue life in vacuum is 10 times more than that in moist air due to, come on, waiting for your answers. You have gone about these general awareness informations. Come on. Fatigue life in vacuum is 10 times more than that of in the moist air, because moist air, moist air acts like electrolytic in nature. This is the statement. Moist air acts like electrolytic, and when it acts like electrolytic in nature, corrosion will be caused by moist air, right? So both the answers A and D, choices A and D are correct answer for this. Let us see how many have given correctly. Rajiv has given D. Vaibhav has given ABD. Rajanish, A only. Abhishek Kumar has given A and D. Very good. A and D are correct answers, beta. Rajanish, correct. A and D are correct answers. Everyone, please be noted. This question is adding to your knowledge bank sometimes. Sometimes, people may ask you in the interviews also. Get ready. So, corrosion is one aspect. And number two is that electrolytic nature of moist air is the reason for the fatigue life to be less in moist air, and it is 10 times more in the vacuum. All right? Good, beta. Good. A and D are the correct answers. Next question. The question is on the screen for you. Question is on the screen for you. Come on, which one of the following alloying elements is used for improving resilience for shock loading applications? Try to answer this. Which one of the following alloying elements is used for resilience, improving resilience for shock loading applications? Vaibhav has answered. Very good, beta. Very good. Utkarsh, no. It's not sulfur. Priyansh was A, correct. Abhishek Kumar Mishra, well, correct. Abhishek. Tushar, C, no. Fine. A is correct answer. While studying the effects of alloying elements, you have studied that silicon increases resilience in steels. Yes or no? Resilience is the important property that is required in the shock loading type of applications. So silicon is the correct element, beta. So correct answer for that question is given by choice A. Raju Kumar, correct. Rolex and Pratik Gupta, very good, beta. Very good. Choice A is correct answer. Silicon is the right answer, beta. Okay. Now let me see if I have anything in the store for you. Yes. This question. Read this. The question is on the screen for you. Question is on the screen for you. Which of the following is used for hardness testing of thin specimens? No. Thin. Answer, please. For thin specimens, it is Tucon. For thin specimens, it is Tucon hardness test. And for very thin specimens, it is Knoop hardness test. Remember that, right? That completes the total session, and we are done with all the questions meant for your presentation. Okay? So I wish you all the best. You have all fared very well in the examination. We have done reasonably good number of questions. Stay with full excitement, and I pray the God for all his best wishes best blessings on you. God bless you with all the best. Do very well. Love to see you as upcoming rankers. Good.